Hello everyone. In this video, we're going to talk about the shape of the distribution of a data set and what is the role played by the shapes of the distribution and what are the things we need to look for while we are looking at the shape of the distribution. So first we need to understand what I mean by distribution of a data set. A distribution of a data set, it's a description, and that description may be in the form of a table, or that may be in the form of a graph, or that may be even in the form of a formula, and that provides us the values of those data values and how often each value occur. Such a description is called a distribution of a data set. We already have seen this definition. Okay, why it is important to know the shape of a distribution? Why? The reason is that knowing the shape of the distribution helps us in guiding what will be the correct statistical method, what will be the right statistical method that will be useful. So if we know the shape of the distribution, we know which suitable method will be applicable for this particular analysis. So knowing the shape of the distribution in advance helps us in determining the suitable analysis, statistical analysis. Okay, how we get the shape? We get the shape of the distribution. It consists of two things. Number one, it consists of a frequency histogram, a relative frequency histogram, and a superimposed a smooth curve. Like look at this one. We have these histograms are there, and what I have done here, I have approximated the shape of this distribution with the help of this solid smooth curve, and this curve is called the density curve, right? So what happened, so one might be wondering what was not good in these histograms, so we need to approximate. We human beings tend to understand more the shapes, tend to understand better shapes if it is expressed as a result of the smooth curve. So this smooth curve helps in understanding what will be the shape of this distribution, right? And right now you can see this shape look like a bell curve. Like this is the bell curve, and we will see in the future lessons it's a very important distribution shape, and it plays a very important part, right? How So this is the one of the shape which you're talking about, the bell shape. So the question that comes to the mind, is this the only shape available? The answer is no. We have some other shapes available, and these are the shapes we are talking about. Look at these shapes. We're going to talk about these shapes one by one. This is the first one. This is the bell shape, right? It looks like a bell. Like this is a triangular shape. This is called a triangular shape. This is called uniform shape. Why it's called a uniform? Because the shape doesn't change. It starts like this and it goes the way all the way. Uniform. Uni mean one, form mean shape, one shape. Right? I will explain these two later. Let's see this one. So what happened in this particular shape? It starts with a hum, and then it has an elongated portion on its right side. This elongated portion, this is technically called a tail. So if the tail is on the right side, this is an indication of a skewness, right? So the skewness is the deviation from the symmetry, right? So this is the tail on the right side. For this reason, this is called a right skewed distribution. Look at this one. We have a hum here, but the tail, the elongated portion, is on the left side. For this reason, this is called a left skewed distribution. Look at this shape. There are two clear peaks, the peak 1, and look at the second peak, the two peaks, and such a distribution is called bimodal. These two peaks are mode means the highest value. We will learn this in third chapter. The largest value, the value that appears maximum number of time is the mode. So bimodal, it has two distinct peaks called a bimodal. If a distribution shape has more than two peaks, 1, 2, and a 3, and so on, maybe how many more than 2, we don't care about it. If just more than 2, it's called a multimodal. So these are the shapes which are which are frequently used in a statistic. But let's see this shape also. Look at this one. This shape comes like this. This is called a J shape. Let's look at this one. It's a J shape, like English J. It goes up, it goes up, it goes up, goes up, and keep on going, keep on going, keep on going, keep on going like this. And what about that? This goes down, 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 and like this. This is called a reverse J shape. This is called a J shape, and this is called a reverse J shape. How you can remember that which shape is to we work with? This is an easy way to remember that. What you do, you draw a curve like this, a U like this, and what you do, you cut it from the middle. You just cut it. Oh, sorry. Just cut it from the middle. Let me do it again. So just do it like this, and you cut it from here. Just cut it from here. So these two portions, this is the J shape and this is the reverse J shape. Okay. So this is easy to understand. Okay. Okay. So but remember that underneath these shapes, we have the histograms, right? They're coming from the histogram. These shapes are coming from the histogram. Underneath these smooth curve, we have the histogram, right? For example, look at this one. Look at this one. This is a uniform. This is a uniform. Why? Because the shape doesn't change. Now look at this one. Let me approximate the shape of this distribution with the help of a smooth curve. Look at that. Not the good one. Let me do it again. So we approximate the shape of this distribution with the help of the smooth curve, and look like a bell shape, right? Look at this shape. Remember, the underlying underneath these smooth shapes are the histogram. They are the defining. These are defining the shape of the distribution. Look at that. I have this one, and I approximate the shape of this distribution with the help of this smooth curve. Since it has a tail to the right side, this is called a right skewed distribution. And look at this one. We approximate the shape of this distribution with the help of a smooth curve, and such a distribution has a tail to the left side. So this is called a left skewed distribution. So these are the commonly used shape of the distribution which we are going to encounter in our course. So what are the things to look for when you're talking about the shape of the distribution? What are the things to look for? Number one, you look for modality, like how many peaks are there. Like if it has only one peak, it's called a unimodal. One peak means it's a unimodal, right? If it has two peaks, it's a bimodal, right? I have shown you in the previous slide what's a bimodal. The bimodal, right? It has two distinct peaks, and if it has more than two peaks, it's called a multimodal. So first thing you need to look for is the modality, that how many peaks a distribution has, right? Next thing you need to look for the symmetry. Symmetry means I can divide the distribution shape into two parts so that the two parts are the images of each other. Let me show you what I mean by that. Let me show you. Look at this one. Look at the shape of this distribution. Like it looked like a bell shape, right? What I can do, I can divide this shape into two equal parts, part 1 and a part 2, and these two parts are more like a mirror images of each other. Such a distribution which has this property, such property is called symmetry, right? So symmetry is a property. If you can divide a shape of a distribution into two equal parts in such a way the two parts are the mirror images of each other, then such a property is called symmetry. And the last thing we need to look for, it's the skewness. Which side is the tail? Which side is the tail? If the tail is on the right side, then we call this as a right skewed distribution. The tail is on the right side. I have shown you in the previous. The tail is on the right side. It's a right skewed distribution. This is the tail. This is the tail of the distribution. And if the tail happened to be on the left side, like this, then this is called a left skew distribution. So you need to see skewness, which means which side is the tail. If the tail is on the right side, then it's called a right skew distribution. If the tail is on the left side, it's called a left skew distribution. One last remark, that while looking at the symmetry and the skewness, one has to be flexible. You will never find an exact symmetry, and you will never find an exact skewness. We have to look for the overall pattern. I hope you understand this video. If you have any question, please write me an email. Thank you.